Hi everyone, welcome back to Chem Help ASAP. Today we're going to be calculating equilibrium constants. Let's get started. I think when calculating equilibrium constants, it's best to jump right into numbers and actually calculate a KEQ. So consider the following reaction. We've got a balanced chemical equation right here. At equilibrium, the concentration of NaCl is 0.8 molars, NO is 0.33 molar, and Cl2 is 1.5 times 10 to the negative third molar. We need to calculate KEQ for this reaction, and then we're asked are products or reactants favored. I first want to write my equilibrium expression for the equilibrium constant. Here is my KEQ. I am using brackets because we have concentrations given to us. Again, notice you are raising each of these concentrations to their stoichiometric coefficients, which is why it's important to have a balanced chemical equation. Now I simply need to plug in each of these concentrations. I do want to note that the problem is specific and says these concentrations are at equilibrium. Whenever you're calculating the equilibrium constant, you need to make sure that you're using either concentrations or pressures at equilibrium. Now let's plug in my numbers. So my NaCl is of course 0.8, that's going to be squared. My NO is 0.33, that is going to be squared, and my chlorine gas is 1.5 times 10 to the negative third, that's just raised to the first power. I just need to do a simple plug and chug in my calculator. I would say just make sure when you're putting this in that you're careful with your parentheses and things are squared that need to be squared. I would just say watch your exponents, watch your algebra here. So plugging this into my calculator, I get 3.9 times 10 to the third. So I have calculated my KEQ for this equation, and now I need to answer are products or reactants favored? Well, this is where we look at the magnitude of K, and we can know if products or reactants are favored. In this case, because our KEQ is greater than 1, our products are going to be favored. Let's do another one. So here is a new reaction right here. It is in equilibrium, it is balanced. At equilibrium, the pressure of hydrogen is 0.0159 atmospheres, bromine is 0.0768 atmospheres, and hydrobromic acid is 0.0569 atmospheres. We need to calculate the KEQ for this reaction. And then they ask us, what is the KEQ for this reaction right here? Well, I'm going to table this second part. Let's just calculate the KEQ first. Writing my KEQ for my balanced chemical equation, I am using pressures here, but again, I'm going to square this hydrobromic acid, and these two are just to the first power. Again, the problem is specific. These pressures are at equilibrium. That is very important. So I'm plugging in my hydrobromic acid, my bromine, and my pressure for hydrogen, being careful with my algebra, and I get a KEQ of 2.65. Okay, so I have completed this first part of the question, calculate the KEQ. Now I need to deal with this second part. Well, what is true about this second reaction in relation to the first? Well, I've simply multiplied this original equation through by 1/2. So it's the same equation, I have just multiplied by a factor, in this case 1/2. So what does that do to the K? It means I need to take my original KEQ and I need to raise it by a factor of 1/2. So I'm going to call this K 1/2. And I'm going to take my 2.65, I'm going to raise it to the 1/2, which of course is the same thing as taking the square root. So my K 1/2 is 1.63. Now let's look at a problem with a little bit of a twist that's a little bit more difficult. Okay, so we consider the following reaction. We've got a new reaction. Yes, it's a balanced chemical equation. A 2.5 liter flask contains 21.3 grams of carbon monoxide, 1.75 grams of hydrogen, and 29.1 grams of methanol at equilibrium. Calculate the KEQ for this reaction. And then what is the value of KEQ for this reaction right here? Okay, I'm going to table the second part. We need to first get the KEQ for our original equation. Let's write our equilibrium expression for this equation right here. And at this point, hopefully you recognize you've got a little bit of a problem. While this KEQ is true, remember these are all concentrations. But what did our problem give us? It gave us grams for each of our species. So before we plug anything into KEQ, we need to first calculate concentration of all of our species. This is the twist, because if you're not paying close attention, you're gonna plug these gram quantities into your KEQ and you are gonna get the wrong KEQ. But we're not gonna do that because we're paying attention. So let's calculate our concentrations. Starting with my concentration of methanol. So I have 29.1 grams of methanol using my molar mass and then dividing by the volume of my flask. Being careful that my grams cancel, I'm left with moles per liter, which is molarity, which is concentration. So my concentration of methanol is 0.3633, and that is molarity. I'm going to do the same thing for carbon monoxide. Again, starting with my grams of carbon monoxide, converting to moles, dividing by my liters, being careful that my grams cancel out and I'm still left with moles per liter. Again, it's really easy to get this flipped and end up with liters per mole. You don't want to do that. I get a concentration of 0.3042. Again, this is molarity because it's moles per liter. Finally, our hydrogen, starting with our grams of hydrogen, converting to moles, dividing by 2.5. My grams cancel. I'm left with moles per liter, and I get a concentration of hydrogen of 0.3472 molar. These are the numbers that I am going to plug into my KEQ. Here we go. Everything is plugged into my KEQ. Now I just need to put it in my calculator and I get a KEQ of 9.91. That is KEQ sorted. Now let's take a look at the second part of this reaction. We want the KEQ for this modified reaction right here. Well, how is it different from my original? It looks like we just multiplied through everything by 3. So how does that change my KEQ? Remember, when you multiply through by a factor, that becomes a power when you're talking about KEQ. So my K3 here is going to be 9.91 raised to the third power, which gives me a K3 of 9.72 times 10 to the second. That is a very common twist on calculating KEQ, is first you have to calculate concentrations. Let's see how a twist works when we're talking about pressures. So we have a new reaction right here. Yes, it is balanced. And it says at equilibrium, the total pressure in the flask is 0.84 atmospheres. If the pressure of PCl5 is 0.5 atmospheres and PCl3 is 0.12 atmospheres, calculate KEQ for this reaction. And then the second part is our products or reactants favored in this reaction. Okay, so again, I'm going to table the second part. Let's just get this KEQ. My expression for KEQ is right here. And again, you'll notice this is part of the twist. I have a little bit of a problem. While I do have the equilibrium pressure for my PCl3 and my PCl5 given in the problem, I don't have my pressure for my hydrogen. So what's going on with that? Well, we need to first calculate our pressure of hydrogen. So in the problem, they do give us our total pressure and they give us our partial pressures of 2 of our species. We are going to use Dalton's law of partial pressures. So our total pressure equals the sum of all of our species that we have in this flask. I know my total pressure, I know my pressure of these 2 species, so I can calculate my hydrogen. Here are all my numbers plugged in, and in this case for units, I want to make sure that my units all match. So I didn't do it in this problem, but another twist or another layer you can put on this problem is to make, say, your pressure of PCl5 atmospheres and your pressure of PCl3 maybe torr or something different. So whenever you are adding or subtracting quantities, you want to make sure that your units are exactly the same. Thankfully, they already are the same in this problem. So my pressure of hydrogen gas is simply 0.22 atmospheres. Now I have everything I need to plug into my KEQ, so let's put all of those pressures in right here, and I get a KEQ of 0.053. Now let's deal with the second part of this question. Are products or reactants favored in this reaction? Well, our KEQ here is less than 1, so our reactants are going to be favored. There are several different ways that you can take these simple calculations of KEQ and add another layer or add a bit of complexity to them. So just be on the lookout for those types of calculations. I hope you found this video helpful, and thanks so much for watching.